My name is Nicholas Foster. I'm a mechanical and aerospace engineering major at Oklahoma State University, and I'm going to present my research on meteorological data collection for three-dimensional forecasting advancements. Now, what I'm interested in is collecting the data that we cannot access right now in the weather. So we have systems that allow us to get very low altitude data, and we have systems like radar that allow us to collect very high altitude data. In between is a gap where we do not currently collect real data. So we use algorithms in order to predict the weather in this gap. I'm creating a SON, which is a set of sensors that will collect weather data like light, humidity, pressure, temperature, latitude, longitude, altitude, orientation, and wind speed. And so this is the same kind of data that is collected using the Mesonet tower system in Oklahoma. This is a system of 120 towers that stand 10 meters tall, and there's at least one in every county. And so this is where we collect a very low altitude data. The idea is that we will be able to take this SON system and equip it to multi-rotor UAVs, like quadcopters, and attach them to the Mesonet towers and have them fly up to a certain altitude and then back down, collecting data the entire way. This will essentially create a virtual tower on 120 systems all across the state of Oklahoma. This data we can then take and analyze to be able to create, hopefully, a three-dimensional weather forecast. So instead of looking on the news and seeing just a flat map and seeing the weather come across it, we will actually be able to look at this in a three-dimensional manner and take out a slice, so to speak, of the weather and be able to analyze it on all three axes, X, Y, and Z. So in order to do this, I've used off-the-shelf sensors and a teensy microprocessor to collect all of the data. All this data is stored on board on an SD card, as well as transmitted back to a ground control station that is running a LabVIEW program that I wrote that takes all of the data, it graphs all of it live, as well as stores it on the ground control station. So if we lose transmission, we have all the data stored on board, and if we lose the SD card on board, we still have the transmitted data. So this project started off working with an aircraft, a fixed-wing UAV named Maria. And the idea of Maria is to be able to fly up in pre-tornadic areas and be able to collect meteorological data. Using these SONs, or in this case drop SONs, we will deploy them out of the aircraft and they will fall and collect that data all the way down. This data will also be used in order to try and find out why two storms that look almost identical, why one actually creates a severe storm like a tornado and one does not. And so going from this project to the multi-rotor UAV idea, we have moved along and started testing with multi-rotor UAVs with the prototype now. And this picture in the bottom right corner is the GPS data collected from some of those tests. And so you can see that we have the altitude as well as the latitude and longitude. And so once we take the data, like the temperature, the humidity, the pressure, and analyze that, we will have all of that data from the points that we took, and hopefully being able to use the same kind of algorithms that are used today, being able to predict the weather more accurately between those 2 points. And so from this point, we will take a multi-rotor UAV like an Iris, pre-program a flight to fly in a grid on multiple altitudes, and fly that around, take that data, and graph that in the same manner to create a three-dimensional forecast. So all of this work has gone into a SON, and this idea came from what NOAA uses a drop SON for, and that's typically in hurricane scenarios, and so they fly an actual manned aircraft out over hurricanes, and they deploy these drop SONs that are about 20 inches long, 2 inches in diameter, which this is nice for a hurricane, but we don't have that luxury with storms like tornadoes, and so must be much smaller to be able to fit inside of just a UAV. So these systems, this SON is really just about 7 inches long and 1.5 inches in diameter. And it will be able to do all of the same things, just used on a UAV platform. So this research is very important for a number of reasons. Growing up in Oklahoma, I've had a lot of experience being in Tornado Alley. And so I know what it's like for the tornado sirens to go off. And so in order to collect this data and hopefully predict systems and storms better, so that maybe we can extend what is now just about 10 minutes of warning before a tornado to something more like 30 minutes or even possibly an hour, it would greatly impact a number of people across the entire Tornado Alley area. So that is what I am working on, and thank you for your time.